a reflection of the braking capabilities of the car. And then side to side, that acceleration, of course, is the cornering or lateral G-force. I have a small rotating wheel that's attached underneath the steering wheel, which then gives me the steering wheel position, again, in relation to the track and time. Those are the two important factors I'm trying to establish here, are all these measurements in relation to speed and time.
We've got a lot of wires coming into the car, and there's a heck of a lot of information getting gathered, but where does it go? How do you all put it all together?
Then once, after our session is completed, we generally run 3 to 5 laps per session. Then come in, shut down, and download or dump the information from this onboard logger into the laptop computer.
This is what this 1.5-mile test track looks like to the driver. High-speed banking, the guardrail only inches away. A series of tricky S-turns. Up on the banking and onto the back straight. And then a quick chicane. And now here is what it looks like to our onboard computer. A mind-boggling overload of information, so we'll stick with the basics. Now, the dot shows the car's exact position on the track, with speed, RPM, and G-forces displayed here. These are the speeds at key sections on the track. This shows the position of the steering wheel. The green bar is throttle position, the red, brake position. We can also look at the steering in graph form, or the suspension at work. This map shows the throttle position at each point on the track. The more blue, the more you're on the gas, and you can see the difference between an average driver and a pro. And this map depicts the speed. Green is gas, red is brakes. The more green, the faster. We can also zoom in on any section of the track. Here's what our computer profiles as a perfect lap. 1 minute 19.4 seconds. But how does a computer decide what makes up the perfect lap?
Once the line is established through the turns, or let's say on an oval track, we can start with the engine power curve, the transmission gear ratios, and make the necessary mathematical calculations. It's essentially a model. It's a computer model, and duplicate what the driver will be doing and come up with a lap time that's within hundredths of a second. It's the ultimate, in terms of the drivers, to approach that perfect lap.
Now let's see how it all works. Today, 3 different drivers will make runs in the specially instrumented Eagle Talon. Emerson, aspiring IndyCar driver Ken Murillo, and myself. Our first run will be based on our own seat-of-the-pants feel. We'll see just how close we can come to perfect. And then we'll see what the computer says. I went first, trying to forget that my every move was being monitored. We picked the lap up on the far banking. The computer's projected speeds are in white. Mine will flash in yellow. I felt pretty good, but already I was 3 miles per hour off. This computer must have an awfully strong motor. Through the chicane, pretty smooth, but still 2 miles per hour down. Onto the banking, a little better, just 1 mile per hour off. Okay, into the S's. Here's where I figured I could make some time. 80 miles per hour, finally faster than the computer. 59 miles per hour, whoops, a little steering correction. The checkered flag, my time, 1 minute 20.8 seconds. Not too bad, I thought. Unfortunately, the computer profiled a perfect lap of 1 minute 19.4. And worse yet, it had spotted a few mistakes in my flawless driving. Remember that little steering correction I made in the S's? Well, as you can see, I also lifted off the throttle. G-forces dropped, and so did my speed. Next, Ken went out. Let's ride along as the computer monitors his driving. smooth and fast. His time, 1 minute, 19.9. Very good, but still half a second from perfect.
Okay, you're all set.
Then it was Emerson's turn. Would the computer uncover the secret of the champion's driving style?
I think every driver has his own style. Some drivers drive more clean, more smooth. And like I say, you look on the stopwatch, you will have a big surprise because they are going quick. But look in the corner, it doesn't look good. I mean, it doesn't look quick. And you see drivers coming very aggressive, putting the car sideways, spinning wheels out, and you get the stopwatch slower. I mean, that's a style.
Emerson's style showed itself on the stopwatch as well. His time, 1 minute, 19.6, the fastest yet. But he too wasn't quite perfect. Where had we gone wrong? We turned to the computer screen for the answer, and we'll see what it had to say next.